Thank you very much, Petra, for your very kind words of introduction, but also for organizing this session. And a special thanks to our audience who has borne the late night slot. And I think we all appreciate your coming here. So, ladies and gentlemen, my presentation is entitled deliberately Affordable Plant-Based Foods, Role in Nutrition and Sustainability. So I think the operative word that I would like to pursue the discussion is affordable plant-based foods, and within that context, what role has nutrition got to play, and if time permits, talk more about sustainability, because as Petra pointed out, this session is all about trying to triangulate those three paradigms. So I have no conflict of interest related to this specific presentation. So let's ask a rhetorical question. What is the state of the world today in terms of people that cannot afford a healthy diet? So this is a heat map, and I think it's an alarming narrative that our report card today says that approximately 3 billion people globally don't have access. So the operative word is access to an affordable and nutritious food. So access to affordable nutritious food includes the fact these foods that they are not able to access are either deficient in vitamins, minerals, proteins, or fiber. But paradoxically, the first and most important priority in human nutrition is to meet your calorie needs. And I want to keep that at the back of your mind, because we'll come back to that importance of calorie needs to be met before we meet any other macro or micronutrient needs. So I think from a semantic point of view, the term affordable is a little bit subjective, but I think the UN agencies and many other government agencies have come to some kind of a consensual narrative to say you would call a diet unaffordable if you and your household are spending more than 52% of your household income on the food that you require to meet your nutrition needs. And that's what we are going to use in our discussion. You can see here in the heat map, there are swathes of Africa where there is a large proportion of people that are unable to afford what we might call a affordable, nutritious food. So I think this is an important report card for us to look at the moving forward into the future. So this is a very interesting descriptor, despite all the contentious narrative that come from defining an affordable diet. It turns out that an affordable diet is around about $3 roughly per day. And as you know, over 1 billion people actually have an income less than $1 a day. So you see that there's a huge gravitas of concern that we need to have as nutritionists to try and develop foods that are affordable to meet even those that are earning less than $3 per day. So I think, therefore, I'm painting a picture of broad narrative and broad in terms of magnitude, and I think this is something that we are going to pursue together. So let's start with our first basic nutritional need, how to get enough calories. And I want to use as a case example something that is familiar to us in Asia. We're going to be cooking rice. So let's assume that you're starting to cook rice and you can't cook rice without water. So I'm going to add 1.5 times the weight of rice and I cook it. It's not adequately sensitive to eat as a gruel. So therefore, I keep on adding more and more water. And the more and more water I add, the energy density of the rice becomes lower and lower, not rocket science. So from about 136 calories per 100 grams of eating rice with 1.5 times water, 6 times of dilution brings it down to 50 calories. So now the rice is ready to be eaten, but actually so incredibly low in calories that you have to add just miraculously just 10 grams of fat to bump up the calorie content from something that's 0.3 calories per gram to 1.1 by simply adding 10 grams of oil. So now the narrative is oil becomes an imperative if you want to make foods that are high in energy density, palatable, and most of all, viscous enough for the child or the adult or the elder to eat in an acceptable way. So this simple illustration shows you the importance of looking through the lens of how do we make foods that are in many parts of the developing world that are highly carbohydrate based. And by definition, carbohydrates cannot be eaten on its own. They have to have water. As soon as you add water, you reduce the energy density of the food, and therefore the only way you can get a palatable food is to add fat. And I'll come back to that theme as we go along. So this tells you something that is quite embarrassing, which is that if you look at most of the foods that are eaten in our part of the world, they are such low calories per gram that you really have to become a hippopotamus to eat 1.5 kilograms of food per session to get your calorie needs. So it tells you the paradox in terms of bulkiness of food and the energy density, which is an inverse relationship. And that's why we need to be cognizant of this relationship between energy density and bulk density of food. So I now want to share with you two important observations. The first observation is that for millions of years we were hunter-gatherers, and the agricultural revolution happened only about 10,000 years ago, and modern food technology as we know it only happened about 200 years ago. But at the point I wanted to share with you is that this exponential growth in human population could only happen that we were able to process and preserve foods out of season. So I think this is a very important point for us to understand, that technology that enables us to live healthy lives was only possible because we could process foods out of season and make it available when it's in season, vice versa. The second point I want to share with you is look at the number of plant species that our ancestors ate as hunter-gatherers. Hundreds of different plant species. These are real data from the Aborigines of Australia and the Toklas of Botswana. So people are eating as hunter-gatherers when we were just a millennia of years ago, over 100 different plant species. And look at us now. We as a society around the world essentially live on 6 staples that feed almost half or 80% of the world populations. And the most principal staples are wheat, rice, corn, potato, cassava, and sweet potato. And of the 3 staples that are cereal-based, the 3 ones are wheat, rice, and corn. So I think the food technologists, in our humble view, is the model-day alchemist. The alchemists of the past were trying to convert base metals into gold, and the technology of today is trying to transform these 3 staples into a cacophony of different foods with different flavor, different texture, different mouthfeel. And you can see that, isn't it amazing that the humble wheat starch or a wheat grain allows us to make over 2,000 different types of foods with different texture, different flavor, different mouthfeel. And I like to use this metaphor to say, who could believe that a noodle and a strudel comes from wheat? And that exactly tells you what I'm trying to say. Diversity of texture, diversity of nutrition, all from one single source. And in fact, it even gets more perplexing and alarming. These 10 major crops, which you can see out on this slide, allows us to make, with a bit of tweaking, 40 to 50,000 different foods in a well-stocked supermarket. Think about it. That a small, narrow taxonomy of plants that we grow can be transformed in the hands of technologists into a variety of foods with different flavor, different mouthfeel, different nutrition, and different acceptability. So the key point that I wanted to emphasize is that the incredible reduction in plant species going from hunter-gathering to modern man, but the transformation that's possible is the way in which we are able to geniusly transform these foods into different textures, flavors, and mouthfeel. But I think this cannot go on forever. So I think the future, we simply cannot depend on this very, very narrow range of staples to feed 9 to 10 billion people. And if we are going to look seriously at making affordable foods for the population at large, then we've got to look at what we call the underexploited or neglected, under-resourced plants, because those of us who live in the tropics are very familiar at the huge variety of plant species that surround us, whether it's in Africa or Latin America or in Asia, that have been used by millennia, but we are completely ignoring. And I think this becomes a very important form of focus in terms of future foods, looking at cereals that are not being used, tubers that are not being used. And I'm going to give you some examples in a minute. So I think what I would like to propose is that we as a group of scientists need to look at the future without parochially depending on the 3 or 4 staples that we are accustomed to from a cultural and a technological milieu. And I think this is happening. As you know, next year, 2023, is the year of the millet. Hands up those in the audience who have eaten millet. I have. Very good. Does it taste quite good? Yeah, there you are. And of course, the reason why millet is becoming a very important underexploited plant is that the plant can grow under incredibly drought-sensitive regions. So it can grow where there is no water or hardly any water. It's a robust cereal, has got very high micronutrient content. So that's how we are now looking at these kinds of cereals. Secondly, hands up those who have eaten teff. Very good. Teff mostly grows in Ethiopia. And I think we have eaten this product called injera, which is like a pancake. And I think teff is another interesting staple that we can look at in terms of the future. So I'm just trying to paint a narrative of saying, let's not ignore what we now call underexplored plants, because in tomorrow we'll simply need it to feed our people, particularly through the lens of the what you would call foods for the less fortunate and what you might call foods for the future. Affordable indeed. So I'm going to give you a couple of examples that we are working in our lab. Jackfruit. Anybody likes jackfruit here? Yes, very good. Petra, have you eaten jackfruit? Next time. Jackfruit is a very interesting fruit that has got a very delectable taste, but the seed inside is normally thrown away. Harjinder, you agree? They throw it away. Now the seed actually has some resemblance to a chestnut, but it is incredibly high in starch. So all the jackfruit that we eat, quite large tonnage in this part of the world, the seeds are thrown away. So I want to posit to you that the next generation of technology is going to valorize these things that we throw away, that are actually being thrown away, and I'll give you examples. So we have been working on jackfruit seeds in a laboratory where we can show that the jackfruit seed makes a very palatable dessert. It can be eaten like a porridge, so therefore these are quite important. And this is a tree from Sri Lanka. My Sri Lankan friends will know. Have you eaten kittul? Yes, kittul is a palm tree, and we take the pith of the palm tree, and it's a very delectable starch that you can get. So you can see breadfruit again is quite popular, not as popular as it could be. So I'm just trying to throw a tapestry of ideas saying, let's not ignore what we throw away. Jack seeds are thrown away in large tonnage. Let's recycle that in terms of what we want to do for affordable nutrition. And so we've been working on looking at saying, how can we market these ideas by saying, look, there are some unusual nutritional properties that you might want to look at. So using nutrition as the plug to get them to use these plants that are not being utilized. So the next example I'm going to give you is mangoes. Mango is a quintessentially popular fruit all around the world. And Thailand is the #1 producer of mangoes in the world. And I'm just going to give you some simple maths. Let's assume that total tonnage of mangoes is about 55 million metric tons. 40% of the mango by weight is the seed, which is 22 million metric tons. And 20% of these seeds is oil. Now, what is fascinating about this mango seed oil is that the fatty acid of the mango seed oil is almost exactly as you'd find in olive oil. So there you are. You have an oil that's been thrown away asunder by throwing the mango seed away. And I'm saying, let's use the mango seed that's been thrown away as a valorization model to get oil. And the rhetorical question is, can mango seeds become the next source of fat in the future? Oh my God, I've got only 5 minutes. Good God, let's run. Okay, so I now want to stop at something very relevant and topical, which is there's a huge interest and discourse about plant-based meat products. And I think that's a very important direction of flow in terms of our issues of sustainability and also carbon capture and all that. But if you look through the lens of what you would call foods for the poor or affordable nutrition, the question would be, are plant protein-based meat analogs going to be the answer? And so you can see a whole variety. So in fact, we know that many of the plant-based meat analogs are actually available in the market. They are actually quite high in sodium, fat, and also there are some issues that we're going to come to. We wrote a paper about this with Daryl, who's in the audience, a couple of months ago. So I want to pause for a minute to think about how do we currently make plant-based meat analogs. What we do is that we deconstruct the starch, the protein and the oil into monocompounds, cassava into flour, soya bean into protein, coconut into oil, and then we reconstruct it. So this reconstruction has never happened in human history. Now, I'm not making any value judgment. I'm simply saying it's a fact of life that this is not what we have done in the past. So the question is, can we make affordable foods by actually jumping from here to here without going through this process? So can we use staple soybean in its present form and transform it by technology at the village level, or call it what you will, into foods that taste and feel like meat analogs, so that it will address the issues of the low income and what you would call affordable foods? So we've been trying to model what will happen if you move from eating a meat-based diet to a plant-based diet. And this is a study we did using a modeling exercise in our lab a couple of months ago. And I want to quickly run through it. So basically, the blue line is the alternative protein diet that was swapped for a animal-based diet, or vice versa. And you can see that there is a very sort of diverse pattern. So if, for example, you look at total protein, not surprisingly, if you're on an alternative protein diet, you get less protein, no rocket science. But in terms of fiber, if you eat an alternative protein, you get more fiber. So I think there's a lot of ups and downs, and I think I don't want to spend more time, but just point out that if you are trying to swap eating a meat-based diet to a plant-based analog, be mindful there are some swings and roundabouts in a nutritional paradigm. Oops, sorry about this, going the wrong way. So, to add to that narrative, we have just started a clinical trial based on 100 subjects, looking at what will happen to your metabolic consequences if I swap all your meals from being a animal-based diet to a plant-based diet. And we are going to be in the process of finishing this study with Daryl in the audience, with Sumanto, and we are doing an 8-week trial to having a head-to-head narrative of looking at what is the cardiometabolic response, protein homeostasis, metabolic health, and body composition. And we'll hopefully present the data in the not-too-distant future. So, I've rattled through, especially with the gong there. So I hope I'm not gone too fast. So I think the greatest global challenge today is how best we can feed the less fortunate. Affordable plant-based foods must become an imperative for all of us in this audience. In addition to focusing on planetary health, let us not forget, but also focus on human health. Very important. Under and overnutrition and micronutrient deficiencies remain a major public health issue in many parts of the world. The application of food technology will continue to play a pivotal role in developing affordable foods and sustainable foods in the future. Our total reliance on 3 to 4 staples is untenable. We need to expand our plants' diversity via exploitation of neglected and underutilized plant species. the application of new technologies to minimize food losses, waste valorization will play a critical role in eradicating human nutrition. Globally and regionally, food companies that address the nutritional needs of the 3 billion people at the base of the pyramid will be both gain wealth and provide health for all of us in the neglected part of the world. And that's the team that does all the work. I just play the music. Thank you very much.